Welcome to this video on the topic of networks. In this video, we'll be having a look at what is a network, and then we'll be going over some of the various pieces of terminology we have when we're describing networks. Now, in short, a network can be described as simply a means of representing connections or relationships between different entities. If we turn our attention to the diagram over here, what we've got is a very basic network. This network is made up of two different types of components. The first type of component being a node, and the second type of component being an edge. Now, the nodes in this diagram are represented by the circles with the letters in the middle, letters simply meaning a name for each individual node, and the edges are represented by the lines linking the nodes together. Now, in the context of this diagram here, a node can take on any number of entities. Such entities could include things like people, locations, or simply computers. Now, if the nodes represent such abstract entities, then the edges themselves represent the relationships between the nodes. In the case of the nodes representing a person, the edge could represent a friendship or a relationship. If the node happens to be a location, then the edge could represent, say, a pathway or a roadway between two towns. And finally, if the node represents a computer, then the edge itself could represent a connection like a network cable or a Wi-Fi connection. Now, when we're looking at diagrams like this, we actually have a name for these, and we call a diagram that describes a network simply a graph. Now, there's multiple ways in which we can represent a network. If we turn our attention down to the two diagrams seen over here, or the two graphs seen here as I should say, we've got two graphs, and at first glance they look different. However, under close inspection, what we find is that looking at the nodes, both of the graphs over here have the exact same nodes. More interestingly, the nodes themselves have the exact same edges that link them together. So if we look at node A and node B, there's a single edge linking node A and B together here, and same as the graph on the side here. Moreover, looking at nodes B and C, there are two edges linking these two nodes together, and similarly there are two edges linking these two nodes together as well. What we have here is a situation where we have two graphs that are called topologically equivalent. So what we find is that positioning of the nodes isn't necessarily important, so long as all of the edges are arranged the same as well. Now, one more thing to take note of is simply looking at the edges over here. What we find is that we have straight edges and we have curved edges. The networks that we look at have both of these types of edges, and the edges themselves, it doesn't really matter the curvature of the edge. So our edges may be curved or they may be straight. It has no impact on the diagram. Moving down, if we've had a look at simple networks, what we can now look at is something called a directed network. Now, in a simple network, as we've seen on the left over here, we've got a network where there are no restrictions in the way in which we may travel from, say, nodes, or there's no restrictions in the relationships between the two nodes. But if we look at a directed network, what we find is that the relationship linking nodes together, they become asymmetric or unidirectional, as in there's only one way in which you can travel. Now, the consequence of this is the way in which we may observe the traffic. So if we look at a regular network and turn our attention to node A, if we examine the nodes we may travel to from node A, we may travel from A to B, and we may also go down to from A to D. However, looking at the directed network, if we try to travel from node A across to B, that's fine, because the arrows themselves say we're allowed to travel in either direction. However, if we try to travel from node A down to D, it's not actually possible, because we'd be traveling against this arrow here. There's no arrow saying we can go from A down to D. So the consequence of having a directed network is that it restricts the way in which we may traverse the network. Looking at another node, if we turn our attention to node B, from node B in a non-directed network, we're allowed to travel from D to A. In a directed network, from B, we're allowed to travel across to A because the arrow says we can. However, we're unable to travel from B down to D. We are permitted to travel from B down to E, and we are permitted to travel from B to C. Quickly finishing this network off. Now, when working with a directed network, the relationships that link the nodes together, we don't necessarily call them edges anymore. Although we do have a few edges in there, we also have a different type of entity which has a name. If an edge is simply a relationship where traffic may flow in either direction, the relationships where you can only travel in a single direction, we call that an arc. So traffic may only flow in the direction that the arrow is pointing in. So take note, in a basic network we have edges where they don't have arrows on them. In a directed network we may have edges, but they're going to be unidirectional in that there are going to be arrowheads saying we can go in either direction. When we have this relationship where there's only an arrow in one direction, we call these arcs. Remember, the terminology between edges and arcs is non-interchangeable, in that if you call this entity over here an arc, then it's going to be technically wrong. These are edges, these are arcs. On top of directed networks, what we also have are things called weighted networks. So a weighted network is where we have edges and arcs and we assign weights on top of them. Depending on the context we're working in, this can be beneficial to have a high weight, or it could be detrimental. So say, for example, if you're talking about a computer network, you might perhaps give the speed of a connection between two computers a rating where the higher the rating, the better, or the higher the bandwidth, the better. However, you could also be talking about latency, so the time it takes for information to be transmitted across a network cable, in which case the higher the number would mean the slower the transfer speed, so that would be bad. But what we're looking at is a weighted network where each arc or each edge, depending on what we're working with, is going to have a numerical value assigned to it. Moving down, we can have a look at network connectivity, or the connections of networks can be described in two ways. On the left here, what we have is a network where every single node is connected in the network. What we call this particular type of network is a connected network. In contrast, what we have on the right over here is a network, so containing the exact same nodes as the network on the left here. However, what you're going to find is that not all of the nodes in this network are connected together. So what we call this is a disconnected network. Moving further down, we draw our attention to the way in which we may travel along a network, or the names we give as we traverse a network. So a network may be traversed, as in we can travel along it. Depending on the method of travel will determine the type of route we have. So if we have two routes seen over here, on the network on the left here, what we've got is we're traveling from C to D to A to B. What this will look like is, what we've got here is we've mapped out something called a path. So a path is a connected sequence of edges or arcs showing a route that starts at one node and ends at another. So you've got a path, as in you're moving from nodes, and you start at a unique node and you end at another unique node. Now the second sort of movement we can have across a network is called a circuit. So suppose we start at the node C over here, and from C we move down to D, and from D we move across to E. We can either go this way or we can go that way. It doesn't really matter. We still get to E. Then finally we go back to A before finishing at C again. So what we've got over here is something called a circuit. We call this particular route of travel a circuit because we start at one node and we loop all the way around, finishing at our starting node. So a circuit is simply a path that starts and ends at the same node. Now, in addition to these types of paths we can travel across, we've also got another type of way of thinking about traveling along a network, and we call it a spanning tree. So a spanning tree is simply a collection of paths which, when observed as a whole, do not contain any circuits. So say, for example, we have this network scene over here. Now the network itself might not be connected up this way. It could be connected such that we could have something that looks like that. But the way in which we travel along this particular network is we might go from C. So what we're doing here is we're connecting paths together. So what we end up with is something that sort of looks like a tree. Now one thing to take note of is that if we, for example, have a path that looks like this is no longer a spanning tree. The reason why this would not be a spanning tree is because we've now got a network inside of this span, or what would have been a spanning tree. So D, F, and A form a network. So the only way in which you can have a spanning tree is if you have a collection of paths. Paths themselves don't contain circuits inside them. So this concludes all of the terminology that we're going to cover at this point in time regarding networks. So in summary, what we had a look at was, firstly, we had a look at the basic definition of a network and the basic entities that we use to build them. So we've got nodes and edges. We had a look at the idea that we call this particular figure over here a graph. The edges themselves may be curved or straight. Similarly, arcs themselves can be both curved and straight as well. We had a look at the difference between networks and directed networks, and the complications involved in having arcs thrown in the mix, so you can only travel in a single direction. We had a look at weighted networks. We had a look at connected networks and the definition of disconnected networks. And then finally, we had a look at ways in which we may traverse networks. So we had paths, circuits, and finally we had spanning trees.